Hopefully y'all enjoyed your week off, or well, more than a week, spring break. But we're getting back into it with chapter 6. Now, again, we've been going over logarithms and properties of logarithms. And what we're looking at today is 3 specific properties that deal with logarithms. And it's expanding and condensing logarithms. So we have the product property that states if we have log base b of m times n, we have 2 things being multiplied together inside the logarithm, we can rewrite it as an addition of 2 logs. So log base b of m times n is going to be the same as log base b of m plus log base b of n. This also means if we have 2 logs with the same base being added, we can rewrite it as a single log with what's inside them being multiplied. Our quotient property says if we have 2 things being divided inside the log, we can rewrite it as 2 logarithms being subtracted. So log base b of m divided by n is equal to log base b of m minus log base b of n. And last one's our product, our power property, which states if there's an exponent inside the log, we can move it to the front and have it being multiplied. So log base b of m to the n is the same as log base b of m times log base b of m. And all this is saying for each one of these here, if we looked at it individually, so if we said log base 7 of 3x, log base 7 of 3x, we have 2 things being multiplied inside the log. We have the 3 and the x. So it says we can split them with addition, saying that we can have log base 7 of 3 plus log base 7 of x. And it could be more than 2, but when we have 2 or more things being multiplied inside of a logarithm, we can rewrite them out with addition of each of the terms. Our division, our quotient property, log base 6 of, we could say 4/7. 4 divided by 7. And with our division property, we can rewrite it, we can expand it with our quotient property, which says that we can take log base 6 of 4, the top, and subtract from it log base 6 of the denominator, 7. Top minus bottom. And our power property just says that we can move the exponent to the front. So we can say log base 5 of 3 to the x, that exponent of x should move to the front, telling us that we have x times log base 5 of 3. The exponent moves to the front as being multiplied. We have multiplication inside. We can rewrite it as an addition of those logs. And division is going to be subtraction. Questions on these so far? Now, whenever we're applying these here, when we're expanding, when we expand, we're going to want to go quotient, product, power. When we're expanding, it out, we're going to go quotient first, apply the quotient property, then our product property, and our last one's going to be our power property. Now the first 2 we're looking at here are natural logs. Now natural logs are going to work the same way as logarithms. It is the same property. So when we're expanding this, we're expanding it out. The first thing we want to do is apply the quotient, our division property. And with logs or natural logs, the quotient property, the natural log of m divided by n, is the natural log of the top minus the natural log of the bottom. The natural log of the top of the fraction minus natural log of the bottom. So the numerator, the top, 5x to the 7th. So the first thing we'll have is the natural log of the top, natural log of 5x to the 7th, minus the natural log of the bottom, which is just y. Questions on this so far? Any questions on any of this so far? Now our next property, because we finished with quotients, we don't have any fractions left in any of these logarithms, is our product. Now the product stated that if we have two things being multiplied inside a log, we can rewrite it as an addition of those logs. Now the natural log of y is by itself, but in the first one we have our 5 and x to the 7th are being multiplied together. So we can rewrite this as the natural log of 5 plus the natural log of x to the 7th. Because natural log of 5x to the 7th can be rewritten as the natural log of 5 plus the natural log of x to the 7th. Questions on any of this so far? And lastly, we have our power property, which says that we can bring any exponents to the front. And the only term that has an exponent is our x to the 7th. So it tells us that 7 is going to go to the front. So the natural log of 5 stays the same. But the middle one, the 7 moves to the front, telling us that we have 7 times the natural log of x minus the natural log of y. And that's as far as it goes, because this is fully expanded. In each of the logarithms, we have a single term and no exponents. 5 is by itself, it's just a single term. X is by itself, y is by itself. This is fully expanded. And most of this is just doing these here so we get comfortable with how these properties work, how we can go from one to the other. Questions on this here? Let's look at the next one. Yes. We want to expand the natural log of 3x to the 5th divided by y. So again, we're going to do the quotient property first, because we have two things being divided inside the log. We can rewrite it as the natural log of the top. So the natural log of 3x to the 5th minus the bottom, which will be the natural log of y. From here, we're going to apply our product property. Natural log of y, it's by itself, but the 3x to the 5th, we do have two things being multiplied together. So we can rewrite this as a sum of the terms being multiplied together. So the 3 and x to the 5th are being multiplied together. So we could rewrite it as the natural log of 3 plus the natural log of x to the 5th. Questions on this here? Yes, then we would apply our powers. So the 5 would move to the front. So the natural log of 3 would stay the same. We move to the 5 to the front, giving us 5 times natural log of x minus our natural log of y. Questions on this here? Let's look at the next one. So the next one we have is log base 6 of 3x to the 4th. 3x to the 4th is inside. Now the first place we're going to start is the quotient. Do we have anything being divided inside the logarithm? No. So we don't have a quotient for this here, so we can move to the product. We do have two things being multiplied. 3 and our x to the 4th. Since we have two or more things being multiplied together inside the log, we can rewrite it as a sum of those terms. So we'd have log base 6 of 3 plus log base 6 of x to the 4th. And then the last thing we're going to need to do is the power. We need to move any exponents to the front. So the 4 will go to the front, telling us that we have log base 6 of 3 plus 4 times log base 6 of x. Any questions on number 5? Any questions on these so far? Let's look at number 6. Natural log of 5 over 12x. And again, the first place we're always going to start is with our quotient. Now, since we do have two things being divided, we can rewrite it as a difference. What's on top goes first, so the natural log of 5 minus the natural log of the bottom, which will be our 12x. So natural log of the top minus the natural log of the bottom. Yes. So before we go to the product, any questions on how we applied the quotient? Now our product, up to this point we've mainly had it in the first one, but the natural log of 5, there's not two things being multiplied, so we have just the natural log of 5. Now our natural log of 12 times x is a product, and we can rewrite it as a sum of the two terms. So the negative, so we have to put this in parentheses because this negative is being applied to both the 12 and the x. Because if it's on bottom, it's going to have that negative in front. Now, if we left, again, asking about the parentheses, if we left these off, we would get this here, natural log of 5 minus the natural log of 12 plus the natural log of x. Because that plus is going to stay on top. That negative is actually being applied to both. And if we did apply it through, really we're saying that we have the natural log of 5 minus the natural log of 12, because that negative is applied there, minus the natural log of x. Because if it is in the bottom of the fraction, that sign in front of it, that natural log is going to be negative, or in front of the log is going to be negative. Either one of these here, I will take it in either form. Questions on expanding? Questions on how we expanded any of this here? Do we feel comfortable with expanding? Yes. Well, the other direction we can go is condensing. We're going to condense it back together. Now, for the most part, most of what we're going to look at, condensing is not going to be too bad. Now, condensing is going to go in kind of the opposite direction that expanding went. So when we condense, the first thing we're going to do is powers. It's going to go in reverse. When we expanded, the last thing we did was powers. So for condensing, the first thing we're going to do is powers. Then our second is going to be our product. And that's it. Now, with powers, one thing I will say is we're also going to take the negatives as part of the exponent. And it's going to make things a little bit nicer, a little bit easier, especially if we have more than one negative term, like the last one where we had negative or minus the natural log of 12, minus the natural log of x. And taking the negative is going to make sense here. So let's actually, and we're taking care of that with our negatives. And because I've thought about this in different ways we can do it and kind of trying to keep it nicer. Because really, doing this here, we would do powers, move any numbers in front to exponent. And anything being added, we would multiply. Rewrite as multiplication, and then do our division. But when we have something like 6, where we have that minus minus, it gets a little tricky. And the easiest way I found, or kind of makes this a little bit nicer, is starting off with products and taking negatives. Now, the easiest product that we have, or not product, our power, is the 3. There's nothing in front of log 9, so it's still going to be log of 9. Plus, we move to the 3 up to the top, giving us log of 2 to the third. Those two we're good with. Now, on the last one, we have minus log of 3. But we're also going to take this negative up. Now, since we take the negative up, it's going to turn that sign to plus. Now, what's the number in front of that log of 3? It is what? 1. But since it's minus, it's really what? Negative 1. So by taking the numbers and any of the negatives, number in front of anything, when we multiply anything and it's not written, it's understood to be, yeah. So it's really, we could say minus 1 times log of 3 or minus log of 3. But the nice thing about this, especially that negative exponent, since we took it up as a negative exponent, we have log of 9 plus log of 2 to the third plus log of 3 to the negative 1. We have 3 things being added. And whenever we have 2 or more things being added, 2 or more logs, same logs, bases have to be the same, we can rewrite it as a single log with what's inside being multiplied together. So we have 9 times 2 to the third times 3 to the negative 1. So our product, if we have 2 or more things being multiplied inside a log, we can rewrite it as the sum of those logs. If we have a sum of logs, we have 2 or more logs being added together with the same base, we can rewrite it as a single log with what's inside being multiplied. Questions on this here? Now, the only thing we have to do at this point here is just make sure we don't have any negatives, anything that can simplify simplifies. Because one of the things that we do have is that negative first power with 3. To make an exponent positive, we move it from the top of the fraction to the bottom, or from the bottom to the top. And as we said already, because if there is a minus in front of the log, it means that number inside is going to be on the bottom of the fraction. It takes care of that. That's why we don't have the quotient, because that negative exponent kind of takes care of that. On top, we do have 9. Now, 2 to the third power, we can do that. 2 times 2 is 4, times 2 is 8. Incidentally, 9 times 8 divided by 3 will simplify. This here, 9 times 8 is 72 divided by 3. Should be 24. So log of 9 plus 3, log of 2 minus log of 3 is the same as log of 24. Questions on how this condensed? We won't always get just a single number, because especially if we have variables, non-divisible terms, it won't simplify fully. We're ready to look at the next condensing. Log of 6 plus 4 log of 3 minus log of 3. First thing we can do is exponents. So we'd still have log of 6 plus, then we'd have log of 3 to the fourth power, because again, our power property says we can take the number out front and put it to the exponent when we're condensing. For the next one, we can move that negative to the exponent with our 3. Now, since there's not a number in front of that log, between that log and the negative, it's just going to be 1. Now, if it had said minus 2 log of 3, we would pull negative 2. We'd pull the number and the sign. Questions on this here? Now, since we have 3 logs being added together, we can rewrite it as a single log with what's inside being multiplied together. So we'd have our log of 6 times 3 to the 4th times 3 to the negative 1. Questions on how we got to this point here? Now, at this point, there are different ways we could simplify it. One, since what's inside this log, 6, 3 to the 4th, 3 to the negative 1, are all numbers, the calculator, the 30xs, will simplify that for us. If we fixed the 3 to the negative first exponent by moving it to the bottom of the fraction and simplifying what's on top, our 3 to the 4th is going to be 81. And this is what? 27? 2. 162. Yeah, because there's different ways we could have gone to getting to this final answer, because 3 to the 4th times 3 to the negative first. Yeah, 6 times 81. What is it? 486 and then divided by 3. Questions on those here? So, let's look at 7. Log of x minus log of 9. Now with our powers and the way we've been doing this, we can pull that negative to the top, telling us that we have log of x plus log of 9 to the negative first. Since we have two things being added together, we can rewrite it as a single logarithm with what's inside being multiplied. And the last thing we need to do is fix our exponents, because we can't leave any exponents negative, which means we'll move the 9 from the top of the fraction to the bottom. And that's it. Yeah, that's as simplified as it gets. Now for this here, we could have just used our quotient property, log base b of m minus log base b of n, and just went straight to log of x over 9. Because we do have two terms, it just follows the straight pattern. Log base b of m minus log base b of n is equal log base b of m divided by n. We could have just gone from straight to it. And it works nicely because we do have two terms. And especially if we have more than two terms, sometimes doing this powers with the negatives does make it a little bit easier, a little bit nicer. Questions on any of these condensing ones so far? You ready for number 8? Now number 8, just like we've been doing, we can do power first. Now since there's not a number in front of the natural log of 4 besides 1, we're not going to bring an exponent up. I mean, we could say 4 to the first power, but that's just going to be 4. In the middle, we'll have the natural log of 3 to the third. And then the last one, we can pull up that negative 1, giving us 12 to the negative first. Questions on this so far? Anything not making sense? Now, since we do have two or more logs being added together, we can rewrite it as a single log with what's inside being multiplied. Now, yes, at this point here, you could grab the calculator and plug what's inside the log, because again, we're not trying to find an exact answer. We can't just type in natural log of 4 times 3 to the third times 12 to the negative first, because it would give us a decimal number. It won't give us what we want. Because if you wanted to, you could take the calculator and do 4 times 3 to the third times 12 to the negative first, and it'll tell us it's 9. Or if we simplified and fix some of our exponents, 12 to the negative first power. To make that exponent positive, we have to move it from the top of the fraction to the bottom. On top, we still have our 4. Now our 3 to the third is 27. And when we do simplify that, we will get 9. questions on this here? Now, one thing that we can use this for is approximating logarithmic values. Now, for the most part, this was very useful, very handy when we didn't have a calculator that can actually solve logarithmic equations. We did have tables for the longest time where they were able to evaluate and approximate certain values of logs, and then we can use those with these properties to find out what they are. Because most likely, we would have a table that would tell us, say, log base 2 of 3 and log base 2 of 7, or pretty much log base 2 of all the numbers from 1 to a certain amount. Now, 3/7 wasn't contained on the list. But because of our quotient property, states that log base 2 of 3/7 is the same as log base 2 of 3, the top, minus log base 2 of 7, the bottom. Our quotient property says that we can split it up this way. And the reason this is helpful as well, I know what log base 2 of 3 is. Log base 2 of 3 is 1.585. And we're subtracting from it log base 2 of 7, which is 2.807. So even though we didn't know what log base 2 of 3/7 is, using this quotient property, it did give us two logarithms that we have the approximate value for. And now all we have to do is subtract these here. 2, 2. And if we subtract 1.585 from negative 2.807, we should get negative 1.222. We all agree with that there. All right. Questions on A. So let's look at B. Log base 2 of 21. Now, we don't have that. I mean, the graphing calculator can tell us what it is. But if we look at 21, is there any way, using 3 and 7, that I can use those two numbers to get to 21? Our factors of 21, yes? Incidentally, what? 3 times 7 is 21, yes? Since 3 times 7 is 21, I can rewrite it as log base 2 of 3 times 7. Our product property states if we have two or more things being multiplied together inside the log, we can rewrite it as a sum of logs. So I can rewrite log base 2 of 3 times 7 as log base 2 of 3 plus log base 2 of 7. And we know what log base 2 of 3 is approximately. They gave it to us, 1.585. They gave us approximately log base 2 of 7, 2.807. Now we just need to add these two together. And log base 2 of 21 is approximately 4.392. Questions on A or B? Let's look at C, log base 2 of 49. Log base 2 of 49. So we need to use 3 and 7, because those are the two numbers they gave us, to rewrite 49. 7 times 7 is 49, or we could say that it is 7 squared. Our exponent property says we can move the 2 to the front, giving us 2 times log base 2 of 7. Now we know that log base 2 of 7 is approximately 2.807. So we can replace that with its log because we know its value. And the last thing we have to do is multiply it by 2. And at that point we could do that in a calculator. Carry the 1. Telling us that log base 2 of 7 is approximately 5.614. Questions on these here? All right, let's look at these here. Log base 3 of 4/5. Now for these three here, they gave us log base 3 of 4 and log base 3 of 5. So log base 3 of 4/5, according to our quotient property, we can say is log base 3 of 4 minus log base 3 of 5. Well, log base 3 of 4 is approximately 1.262. And we'll subtract from it log base 3 of 5, which is 1.465. Right? 0. And we subtract 1.262 from 1.465, we should get negative 0.203. Questions on A? Let's look at B, log base 3 of 20. Well, 20, using 4 and 5, how can we rewrite 20? 4 times 5. Since we do have a product inside our log, we can say that this is the same as log base 3 of 4 times log base, or plus log base 3 of 5. Since we have 4 and 5 being multiplied together inside the log, we can rewrite it as a sum of the two logs. And again, it did tell us log base 3 of 4 was 1.262, and log base 3 of 5 was 1.465. And now all we have to do is add these together. $2.727. Now our last one here, log base 3 of 25. 25 is 5 times 5, or 5 squared. Now since we have 5 to a power, we can move that number to the front. So we have 2 times log base 3 of 5. Now they told us the value of log base 3 of 5 is 1.465. Then if we multiply that by 2, that'd be 0. 1, 3. 2.93 or 2.930. But that's it for that one there. Questions over anything we've done so far? We'll finish the last of this